He's the Chief Technology Officer of one of the biggest and most ambitious blockchain startups out there. Their goal, in the words, at least on their website, is to bring global payments out of the disco area. Now, I quite like disco myself, but still. So please, ladies and gentlemen, give it up and get down for Ripple CTO Stefan Thomas.
Hello, everybody. I'm very happy to be here today, and big thanks to Elliot and all the organizers for inviting me to address you today. I consider it a great honor to be opening for an event that has so many amazing speakers and just such a high caliber of attendees as well. This is how you get in with the audience, by the way. Just give them a compliment right at the beginning. Now, for me, this is a bit of a special talk or a special occasion because this will be my very last presentation as CTO at Ripple. I am starting my own company. We are receiving some funding from Ripple, and it's building on a lot of the technology that I've been working on before and while I was at Ripple. Yeah, so this will be somewhat of a special occasion for me anyway. And it's kind of fitting to be speaking here in Switzerland for that because this is where I was living when I first got into Bitcoin back in 2010. I had been involved in some startups here in Switzerland that I helped to set up. And after selling the last one, I was kind of looking for something new to work on. And I came across Bitcoin.org, and the rest sort of is history. And I still associate a lot of fond memories, especially those early days are always the most exciting for any project because it's all new and you're kind of, what does it all mean? And you try to figure it out. I remember we started the Swiss Bitcoin meetup, and the first meetup had about 6 people. And I hear that it's a lot more now. So I think we're doing well. So what I want to talk to you today, and I've titled it Separation of Consensus and State. Maybe more accurate would be separation of logic and state, but then it wouldn't really be blockchain related, so I've put in consensus and also to kind of recall the church and state idea. And basically what I mean by that is we currently have these very integrated monolithic blockchains. And so I want to think about other architectures, and I don't expect everyone to agree that there's one right architecture. I think that it's a good thing that everyone has sort of their own ideas of how blockchains should be built. But hopefully you'll find my viewpoint interesting because I think it is pretty unique. Now, you might have heard this saying before. It's a very popular sticker. So if you spend any time around tech people, you might see it on their laptops. And obviously it's a bit tongue-in-cheek, but what it's referring to is the fact that when you store your photos or your personal information in the cloud, it's not this magical place that lives outside of physical reality. It's a real server somewhere that somebody's running and that could theoretically be hacked or even physically accessed. And so it's sort of a reminder to be careful about what data you share and where you put your data. And it's also a little bit of a rebellion against buzzwords. And so I want to introduce a similar phrase for the blockchain space, which is, there's no blockchain, it's just someone else's computer. And so what I'm talking about is, even if you're using a blockchain, and even if it's Byzantine fault tolerant, you're still running on some physical computer somewhere. And it's important to remember that. And whenever you're evaluating using a blockchain for some business purpose or even setting up your own, you should always be thinking about what are the actual servers or computers that this is actually going to run on in the end. Because it matters, because it influences the security, and it impacts what you can do with it and how other people could attack it. Now, obviously using the most prominent example of a running production blockchain, Bitcoin, The physical servers that are doing the validation and that are deciding the ordering of transactions are the miners, more specifically the mining pools. And so a lot of you might have seen this chart before. This is sort of the current hash rate distribution. And this has been changing a lot over time. I remember there was once a very large pool called DeepBit, which is now basically defunct and non-existent. And so, new mining pools come and go. But these are the companies that are actually validating your Bitcoin transaction when you make one. And most of them are in China. All of the named ones here are in China except for Slushpool, which is in the Czech Republic. And that's actually, fun fact, the oldest pool. Now, I lied a little bit because 2 of these pools are actually owned by Bitmain. So the 2 largest happen to be owned by Bitmain. And so more accurately would be this kind of hash rate distribution. And so when we talk about Bitcoin as this trustless system, we have to think about, well, it is trustless as long as you don't count the trust that you have to have in Bitmain and some of these other mining pools. And some people counter, well, the miners can withdraw their support for the pool, and that's true. However, they can't do that in real time. They're going to be doing that over time. If the pool misbehaves, they're not going to be able to stop a double spend attack as it's happening. And so, in terms of evaluating the security of a consensus algorithm, you really, to be fair, you have to look at what can somebody do as part of the algorithm, not what is some out-of-band mitigation. Because if you allow for out-of-band mitigation, pretty much every consensus algorithm is going to be secure. Now, choosing these validators, that's sort of the fundamental problem that any consensus system has to solve. If you want to have a distributed system, and again, we want to think about who are the actual nodes that that system runs on, well, you have to choose them somehow. And Bitcoin uses a process called proof of work, as we all know. And it's a very expensive way to select validators. And you might say that it's the only truly decentralized way, and that's a fair statement. However, it's also a fact that it's an extremely expensive way of compiling a list. So you could call this list the most expensive list in the world. And this number is the amount of money that's been spent on mining this year so far. And it's actually on pace to more than double what the network spent last year. Now, if you wanted to put together a list of validators, you wanted to say, okay, who are the best nodes that we should have as the operators of our financial system? You would probably say, well, they shouldn't all be in one country, they should be globally distributed. You'd probably say that they should have very secure data centers. Maybe you care about their sort of mentality, mindset, values, and so on. And maybe there isn't like one set of validators that everyone in the world would agree is the best one. And so it's actually not so easy to find that one group that can run a global system. And so you could say maybe we need the proof of work in order to do that. But you can also take the opposite position, the opposite view, and you can say, I want to be in this business. I want to be in the business of making a list and getting paid $3 billion to do it. That seems like a pretty good business to be in. I'll even undercut them. I'll give you a better list for just $1 billion. And let's leave it at that. Now, I've been thinking about this problem for a long time. And I could be talking about Xrp Ledger, which is a consensus ledger, a blockchain, public blockchain, that also uses a form of explicit node selection. So essentially the way it works is that if I want to participate in the Xrp Ledger system, I need to select which nodes I'm going to be listening to. Other people do the same. That forms a graph, and we can start to analyze that graph, and we can create an algorithm that has certain properties given a certain graph. And by definition, the validator selections will be in the interest of the users, because the users are making those validator selections. The downside is it's not an automated process. With something like Bitcoin, you get an automatic selection of nodes. So it's really dependent on your use case. If you have a system and you want it to be totally anonymous, it's very hard to select nodes, because if they're anonymous, you don't really know who's behind them, if they're trustworthy or not. And so proof of work is a pretty reasonable way to do that. But if you actually know who the nodes are, and ironically, even in Bitcoin, we now know largely who the mining pools are, why not just select the ones that you want and save yourself $3 billion? But I'm not going to be talking about Xrp Ledger today. Sorry for some of you that might be disappointing. For some of you, it might be a relief. Either way, I'm not going to be talking about that very much today. But while I was at Ripple, I worked on a project called Codius. And Codius is essentially a smart contracts platform. And it came from our desire to do smart contracts on top of Xrp. And originally, we started with an architecture all the way back in 2013, early 2013, that is very similar to what you would now recognize as sort of the Ethereum architecture, which is you have a Turing-complete sandbox that is running on each node in your blockchain system, and then you come to consensus on those computations, and that's how you mutate your state, and therefore you have a programmable blockchain. Now, as we were working on that, there were several reasons why we didn't actually deploy that solution. Number one, we thought that it vastly increased the attack surface of the system. So if you have programmability in your blockchain, the blockchain is already a fairly complex system. It has consensus, it has state, it has politics involved with it, it has potentially currencies, it has economics involved with it, all kinds of complex incentives. And yeah, in general, any distributed system will tend to be pretty complex or pretty difficult to reason about. As hopefully I know there's a lot of really top experts in the room, so I don't have to tell you. And so we didn't want to add that another dimension of complexity, because it's not just sort of linearly increasing how complex the system is, but rather it's adding a dimension to all the other axes of complexity that are already there, because now people can run their own code and they can use that to interact in weird ways with the consensus, or interact in weird ways with the economics and the incentives and so on. Now, the other problem that we saw was if you're running it directly in the blockchain, unless you're doing something else that's clever, your contracts have to be deterministic, because if every node runs your contract and everyone comes to a different result, your blockchain will fork, and that's not a very good blockchain if it constantly forks. We actually got around that problem with a little trick, which is basically to come to consensus on the result of the computation instead of the computation itself. That's something you can do in consensus systems that are more along the lines of traditional consensus systems like PBFT type systems, or you can do it with something like Xrp Ledger consensus. You can't really do it with proof of work because there's one node that chooses the next block, and so everyone else needs to be able to come to the same result to be able to verify it. But if you have some form of voting about what the next block should be, then you can tolerate some difference on the result, and so you can use that to come to consensus on what the result should be. And so what that does is it means that people can write contracts that aren't always 100% deterministic. As long as they tend to be deterministic, it'll still work. Anyway, another big limitation of doing your calculations in the blockchain itself is that it's very hard to address other systems, to talk to the outside world. And people have traditionally gotten around that by using something called an oracle. So the idea is that rather than having your actual business logic call out directly to other systems, you have a separate installation system that looks at these outside systems and writes the data into your blockchain. Now, just from how I explained it, you can probably tell that that's a fairly clunky thing to do. It's not what we do in traditional enterprise software architecture, where if you want to call some outside API, you go call that outside API. And so you really restrict yourself by having your code run alongside your data. And that's something that people already discovered way back in the 70s when we were using mainframes and we had big big, large-scale databases, and we would write our code as what's known as stored procedures. So really, you just write your business logic right next to your data in your database, and that works great as long as all your data is in that one mainframe. But if you're dealing with another company or maybe another branch of your own company that has a different mainframe, things tend to get very complex very quickly because that's not a very flexible programming model. So with Codius, our big idea was to copy that lesson, to basically learn from the past and say, okay, we moved away from mainframes, we moved away from stored procedures. Well, what did we move towards? And what we moved towards was separating our state from our logic. So we would have these stateful systems, which are complex enough, and all they're really supposed to do is worry about holding that state. And then we have a bunch of stateless systems, which is where we implement our business logic. And this architecture has become so successful, it's basically ubiquitous. And that's how most enterprise or even other kinds of applications are written today. And so with Codius, we try to imitate that architecture. So basically how it works is a Codius host is a sort of isolated system. There is no built-in consensus mechanism. There is some level of a distributed network because you need to find those hosts. And so there is a gossip network that is used for discovery. But other than that, the hosts don't really interact with each other as part of the core protocol. And so if I'm a user and I want to run a smart contract, well, all I would do is I would implement a smart contract and I would upload it to however many hosts I want. So I can say, hey, I want this smart contract to be ultra decentralized. I want to choose 100 hosts. Or I can say, hey, I just need a small number of hosts to have some Byzantine fault tolerance, but it's not like the end of the world if this goes down. So I'm only going to upload it to a few hosts. Or maybe my particular application that I'm trying to upload is very performance sensitive, can't handle a lot of nodes, and so for that reason I want to use fewer ones. So whatever your constraints are, you can kind of choose the number of hosts that you want. And what Codius does, like you might say, this looks a lot like just hosting, and you wouldn't be too far from the truth. It is mostly just hosting. But there's one thing that Codius does that's unique, which is after you upload the code, the host tells everybody what's the code that you uploaded, and crucially, it doesn't let you change it. So if I upload something to AWS, I can later come in and modify what it's doing. I can take an image of the hard drive and download it. Codius won't let you do any of those things. It basically just says, give us a immutable image of your code. You can upload that, and we'll run that for you, but we won't let you SSH in or anything like that. And so what that means is that if I'm now somebody else who's kind of looking at that, I can verify that the code that's running is the code that I want to have as my smart contract or application or whatever it is, and I can trust the fact that the uploader didn't tamper with it. Now, of course, some of the hosts could be malicious, and we'll deal with that in a second, but I don't have to trust the uploader as long as I verify that image, which you always have to do. So suppose you have this classical consensus application. It has a fault tolerance of 3f plus 1, so you can tolerate 2 faults for these seven nodes. And let's say 2 of the hosts fail, and our uploader is also malicious. So in this particular case, this application would still be running correctly because the algorithm that's running on those 7 hosts has that fault tolerance, and we're not trusting the uploader. We can trust the honest nodes that are saying, hey, we're running this particular hash, that they are actually doing that because they're honest nodes by definition. And the hosts that are Byzantine don't matter because the algorithm doesn't break down if we have 2 failures. So that's the basic idea behind Codius. It's a system for deploying decentralized applications. One thing I want to point out is that surprisingly, the system is useful even if you just upload something to one host. And what's kind of important about that is because writing applications that are centralized is actually totally different than writing distributed applications. Again, a lot of experts in the room that I don't have to explain this to. And so there's a lot of use cases where, let's say, I'll have an example later, but let's say I want to do some sort of minor contract over a few dollars. I'm not really expecting that AWS will risk their reputation, Amazon will risk their reputation to defraud me, right? And so if I have a reasonably trusted host that I can upload things to, that's very useful. And crucially, Codius still protects from a malicious uploader. Because again, the host still verifies that hash, or this host still provides that hash that any other party can verify. So it's useful even if you're just uploading it to one server, which is quite interesting. So this is a really weird comparison, but I threw it in here just because most people today, when they think about, okay, I want to write a smart contract, they think about doing it on Ethereum. And to the extent that people have built working smart contracts, most of those are on Ethereum. So I think it bears comparison. So if you write a contract for Ethereum, the consensus mechanism of that contract will be proof of work and whatever else that Ethereum migrates to. And actually, this migration aspect is pretty interesting because, I'm not necessarily saying that Codius is better. I'm just saying that it's different. And one of the advantages of something like Ethereum is that you don't have to worry about any of this upgrading that the Ethereum network might do. So if Ethereum switches to a different consensus mechanism and that one's better, you didn't have to do anything. You were basically along for the ride. Now, you can flip that and you can say, well, what if they make a change I don't like? Well, you're still along for the ride. So that's the trade-off. Next, in Ethereum, all the state is global, so everyone kind of sees all the state of everyone. With Codius, generally the state would be you're writing your decentralized application, you're uploading it to these hosts, and so they might share state with each other, but it's kind of contained. And the only way that you would share state is through APIs. So if I'm just a client of the internet and I'm looking at this Codius system, I can't see any data of any contracts. So that could be, again, a benefit or it could be a downside. If you're looking for that transparency, it could be a downside, although if you trust the host, you will still be able to have an API where they provide that data, either unconditionally or under certain conditions. So I think this one is one that the additional flexibility that Codius provides is actually very powerful because you can have private data without having to resort to any kind of really complex zero knowledge proofs or anything like that. In terms of the virtualization, so Ethereum has its own virtual machine, EVM. There's a lot of talk about using other technologies, but that's what's there today. And Codius uses the Zen hypervisor. So actually, is this true? Well, it's using hardware virtualization. I'm not sure it's Zen, but it's hardware virtualization. And then next, you have the programming language. With Ethereum, you can write in Solidity and a handful of other sort of EVM-compatible languages. And what that means is your contract has to be deterministic, so you can't just go ahead and make an HTTP call or anything like that. You have to have something that is self-contained, only accesses state in Ethereum, and then you're good. With Codius, you can write it in any language, so that already opens it up to vastly more developers, which once again is a two-edged sword because, those developers might not all be great at writing smart contracts. Next, let's talk about the hosts and the validator. So with Ethereum, there's a certain set of hosts that are that have a majority of the hashing power, and the same will be true once it switches over to proof of stake. There will be certain hosts that have a lot of stake, and so that would be your base of validators, and you don't have any control over that. In Codius, it's once again, as I described before, a choice of the individual uploader of the contract, what host that it uses. And one thing that's interesting is that the upload of a contract can be another contract. So what that means is that you could write a contract that has some kind of logic for how it migrates to different sets of hosts. So there could be a feature that lets the users of the contract vote on which set of hosts to migrate to add a host or remove a host, or things like that. So there's a lot of flexibility, but once again, it's up to the uploader to figure that out. And then finally, the cost is very different, and it's hard to actually compare because in Ethereum, you pay per transaction. So essentially, every write you do to your transaction state costs you money, whereas in Codius, you're paying for hosting, so you're paying per host per month. And so Ethereum could be much cheaper if you have an application that doesn't do many writes and runs for a long time with few users. But if you're trying to build a very scalable application with a lot of users, almost certainly Codius would be cheaper because $5 a month, during that month it could be doing millions of writes, and so it could be millions of times cheaper in that scenario. Now, we launched Codius, it's an open source project about 2 weeks ago, and thankfully it got featured on CoinDesk, and so a bunch of people started to pay attention to the project, and so there's already 150 hosts out there up and running. And this has actually highlighted a lot of bugs in the implementation that we're working through, so bear with us. But I would call that fairly successful. I'm actually very excited about this map, which is the actual locations of these 150 hosts according to GeoIP. And so it's a fairly distributed system. And what's empowering to me about that is, if I'm using something like Bitcoin or Ethereum, I'm pretty much restricted to that very 81% China-located set of validators. I don't have any control over that. With Codius, I can today make a contract that is entirely Australia-based if I want to. And so I have a lot of control. And I'll give you some examples of what you could do with that control. So the first use case would be something that a lot of people have run into, which is, okay, I've implemented my smart contract on Hyperledger Fabric, and now I'm ready to deploy it. But my consortium has 3 members, and I want to have a Byzantine fault tolerance of 2, so I need 7 hosts. What do I do? And so one option you could do is you could upload it to Codius. You could pick the number of hosts that you want, upload it. You can pick the criteria that you want, so you want to have it geographically distributed or whatever. You can put that in. So it's actually a very powerful way to run private blockchains. Now, right now, Codius only offers HTTPS access, so it's not actually possible to do this today, but I'm working on a solution for that, which is basically a VPN solution that ties your hosts together so that they get a virtual IP range, and then you can have any applications running on there. So that should come out in the next couple weeks. So this is a really good use case. And this is something that resonates with me as well at Ripple, because we needed to get our Xrp Ledger a blockchain running on a bunch of different validators, and it was basically a business development effort. So it was going out to companies saying, hey, here's why you should run a validator, here's the benefits for you. And so that's a very manual and time-consuming process, and this basically turns that into a single click, right? I can say, upload to 20 hosts. Oh, actually, 30 hosts. There you go. Now, you can get even crazier because Codius is accessible over HTTPS. It's not behind a weird custom blockchain protocol. It's just HTTP. And so you can actually run something like a content delivery network. So you can have, and this is not an application that you need to worry about your security, because you can use integrity hashes in the browser that make sure that the content only loads if it's the right hash. And so you could have a piece of JavaScript, figures out what's the nearest Codius host, and then load some content from it. So it's useful for totally different use cases as well. Another example would be, what if I want my blockchain to be really low latency? So kind of think of a game, maybe like a game where latency is very important. And so I don't want a globally distributed blockchain that takes 2 seconds to come to consensus. I want something that's more faster, and the best way to do that is to make it regional, because it speeds up consensus systems quite a bit if the latency between hosts is smaller. And then finally, this example I hinted at earlier, which is, hey, if I just need to make a little bet on the World Championships or the World Cup, why don't I just upload it to one host? It's not like AWS is going to defraud me just so they can steal the $50 on my sports bet. Now, we built this all the way back in 2015. We had a fully working prototype of Codius. Well, I say fully working, well, with one exception, which is what I'm about to tell you, which is, how do you actually pay the hosts? So we could say, hey, you can upload things to my server, but you got to pay me for that, right? And we could have said, well, you pay with Xrp, and so it's kind of tied to the Xrp Ledger. The problem with that was that, well, as you all know, Ripple has a certain reputation in the blockchain space that would have excluded a lot of people from wanting to use it. And so you would have ended up with an Xrp Codius and then a different Ethereum Codius and a Bitcoin Codius over there, and they would have all been mutually not interoperable. And so, despite the fact that we had all this developed in 2015, we kind of sat back and said, we can't do this. This is not, there's something missing. We can't do it as is. We don't want to tie it to any particular ledger. This should be across all the ledgers. And in order to do that across all the ledgers, you really have to solve this problem. How do you pay hosts without saying, like, oh, you pay them with token X? And the reason this is an issue is because today's blockchain are these sort of weird monoliths. So they're integrated. They have payments and tokens and consensus all bunched into one. And so this is the problem that we need to address. Here we go. Here's another view of that. So if you have CryptoKitties that's running on Ethereum, that can't you can't pay with XRP for that or with Bitcoin, unless you do something outside of the blockchain to convert it. And so a lot of times these applications stay within the community that created them rather than being sort of usable on any system. Now, this reminded us of a certain other system that solves a similar problem, and I'll show you this. So imagine if somebody wrote Skype, but they wrote it on top of Ethernet. And so it only works on Ethernet, and you can't do Skype calls over Wi-Fi. And that's exactly what we're talking about. It's like you have a single network, and within that network, the application works, but as soon as you go to a different network or even across networks, it stops working. And the same with BitTorrent, the same with email, and so on. Now, what was the solution? You all know it. It's the internet, which acts as an abstraction layer and as well as a routing layer to go from one network to the other. So I can actually, not just can I use any network, but I can be on one network, you can be on another network, and we can be part of the same interaction. Incredibly powerful. And this is why the internet became so big, is because it has insane network effects, because we can be on the plane emailing, you know? And this is something that hasn't happened for the blockchain world yet. So this is what we set out to fix back in 2015. We released a white paper, IntelliLedger white paper, in October of that year. And I'm happy to announce that IntelliLedger is done. It works, and we're starting to use it for stuff. And so I could imagine some sort of future CryptoKitties that builds on IntelliLedger instead of Ethereum. And so, you know, I can use Bitcoins, I can use XRP, I can use Ethers. Doesn't matter. I can interact with this application regardless of whatever blockchain I like. And so this would allow this industry to start building applications with much greater network effects than was possible before. Now, just a few points about IntelliLedger. IntelliLedger is a streaming payment solution, so it sends very small packets of money. So rather than sending whatever amount you're trying to send all at once, it actually splits the payment up into tiny chunks, sends individual chunks across, and then kind of reassembles it. You lose atomicity with that, but you gain a lot of cost efficiency. And so once again, it's sort of a trade-off. And I kind of compare it to packet switching versus circuit switching, which is how the phone system used to work. So in circuit switching, you get a dedicated channel, and so then you can have your phone call over that channel. And the internet introduced packet switching, which is essentially your data gets split up into tiny packets. Now, if you're trying to make a phone call, splitting up into tiny packets can actually be quite terrible, because your phone call cuts out, and there's like delays and so on. And so it's not the ideal solution for all use cases, but having everything on one system is so powerful that even phone calls are now done often over IP. So it's a very interesting paradigm. And it somehow, we realized that it applies to money, which didn't think that it would, but it does. And so if you think about all the different kind of token systems that are out there and all these different ICOs and whatnot, and I picked 3, and I really don't want to be talking negatively about them or anything like that. The reason I picked these 3 was because I looked at the list of the largest ICOs, and I picked 3 that I could actually understand what the hell they're trying to do, which eliminated a good chunk of the top 50. And so take this as a compliment for these 3, not as a knock. But basically, what I want to say is that this concept that we used within Codius as a way to make if you want to call it that, a different kind of Ethereum, that actually applies to a lot of different use cases. A lot of different use cases that people are currently imagining that they would build blockchains to serve. And so you can re-architect all of those using IntelliLedger. And so suddenly you can have paid IPFS, and you can pay with Ether, or you can pay with XRP, you can pay with Bitcoin. So your tokens become universal. And I mean, it's not surprising, because you don't go to the clothing store and you spend your clothing tokens. You go to a clothing store and you spend dollars most of the time. And there might be loyalty programs, but those are intentionally non-fungible. So I think they're not a good comparison to most utility tokens that people talk about. Although there is some similarity. And so if you think about some user and some host, and they're currently transacting using, let's say, Filecoin. Again, I don't want to pick on anyone in particular. Insert whatever your favorite, or maybe your least favorite utility token. And so the hypothesis is that people will use it for that particular use case. But think about it from the perspective of a file host. If I'm a file host and I'm accepting payments for people to store data on my server, I'm going to have costs in other that's denominated in other currencies, like maybe dollars, maybe other crypto, probably dollars. And so I need to actually convert that. And so the more liquid the token that I accept, the better. And so I'm going to start accepting also Bitcoin, Xrp, other more liquid tokens, whatever has the lowest cost to me, and I'm going to prefer those because why not? Like, it makes my life easier, it lowers my costs. And funnily enough, the same thing is true for the user side. As a user, I don't want to have to go and convert whatever tokens I have to Filecoin first before I transmit them. I just want to use whatever is the most liquid and the most efficient. And so the key takeaway that, at least for me, and I'd be interested to see if you guys agree or not, is wouldn't this apply to most use cases? Wouldn't this just be easier to use universal tokens? And so my hypothesis is that users will choose the most liquid, the lowest fee tokens, regardless of what use case they're trying to address. All right, so with that, here's a bit of a summary. I think that this is a total different view on the blockchain world. This is a totally different architecture that I don't hear talked about a lot. So I hope you guys can go out there and talk about it. And yeah, I'd be interested to see if people agree, if people disagree. So feel free to tweet at us. I'm Just Moon. By the way, I did not pick that name with Moon, the blockchain term, in mind. I picked that term back in 2004 or something. And then my new company is called Coil, so you can also find us there on Twitter. And then all of the stuff I talked about with Codius, the best place to go right now is to go on Medium. We're posting a bunch of tutorials there. So if you want to play around with that and try it out, go to Medium, go to GitHub, and try it out. So yeah, that's about it.
Thank you to Stefan for kicking things off in such spectacular style. And as he mentioned, I think you're leaving Ripple soon, is that
Yes,
right?
yes.
So, and your new company is called Coil.
Yes.
So when we see you next year on stage at Crypto Valley,
that's up to you.
2019, you'll be here from Coil.
That's right. Yes.
Okay. Well, I'm sure you'll join me wishing Stefan best of luck in his new endeavors. And thank you very much.
Thank you.